Hey there, it's Mr. Estrada here, and our learning target says I can sketch the locus of points equidistant from 2 points. Let's begin with a scenario. Suppose that you are playing a game of paintball and 2 of your friends are hiding behind trees. Where could you possibly stand so that your firing distance to each friend is exactly the same length? So I'm gonna draw 2 dots here. And each one of these dots will represent your friends. So we're going to say this is friend 1, and this will be friend 2. And they are hiding behind trees. So let me just draw a tree here. Not so great. I'm not really the best artist, although I am an admirer of art. But we'll make do with the talents I have. So there are your 2 friends, and they are hiding behind trees. And the question being posed is, where could you possibly stand so that your firing distance to each friend is exactly the same length? Now, the first thing that would come to mind is, well, you could stand right in the middle. So the red dot will represent you. So, because if you stand in the middle, the distance from you to friend 1 will be the same as the distance from you to friend 2. So you'd be, the same distance from both of your friends if you stand right in the middle. But of course, as you've seen with these locus questions, you always have to ask yourself, well, is there another place where I could possibly stand so that the firing distance to each friend is exactly the same length? What if you also stand right over here? Wouldn't the distance from you to friend 1 also be the same as the distance from you to friend 2? It would, wouldn't it? It certainly would. And I can actually prove that to you, and I will prove that in a second, but let me just keep going. What about standing over here? Or what about standing over here, right? The distance from here to friend 1 and the distance from here to friend 2 is exactly the same. So if you actually stand anywhere on this line that is actually the perpendicular bisector, so anywhere on the perpendicular bisector, you will be exactly the same length from both of your friends. That's called equidistant. So equidistant means exactly the same length. Whoops, let me just spell that correctly. Same. So equidistant means exactly the same length from 2 objects in our scenario. So anywhere on the perpendicular bisector of these 2 points, you will be exactly the same length from friend 1 and friend 2. And I said I would prove it to you, and here is how I would prove it. Say you are standing at this point, for example. If you draw a line from this point to friend 1, and you draw a line from this point to friend 2, I mean, you can actually measure them, and you'll see that they both measure the same. But another way to think about it is like this. What if I connect friend 1 and friend 2 here? You'll see that you actually have an isosceles triangle right over here. So these 2 lines are equal. That's one way to look at it. Another way to look at it is if you know the distance from friend 1 to the midpoint here and the distance from here to where you are standing, you can use Pythagorean theorem to find this distance, and you'll see that it's equal to this distance here. So to summarize, you can essentially stand anywhere on this dotted line and you will be exactly the same length from both of your friends. That's called equidistant. So let me give you the theorem formally. This is Locus theorem 3, equidistant from 2 points. The locus of points equidistant from 2 points, P and Q, is the perpendicular bisector of the line segment determined by the 2 points. Let's try one more example. It says, sketch the locus of points equidistant from A, negative 5, 4, and B, 1, 4. Give the equation that represents the locus of points. So first, I'm going to begin by plotting this point and this point, point A and B. So A is negative 5, 4, right over here. And B is 1, 4, right over here. So sketch the locus of points equidistant from A and B. So you know you're going to deal with Locus theorem 3, equidistant from 2 points. So that just means you need to draw the perpendicular bisector of these 2 points, which would be this line here. And that's it. Those are all the points equidistant from A and B. This line represents all the points equidistant from A and B. Anywhere on this line, you will be equidistant from A and B. For the second part, it says give the equation that represents the locus of the points. So the equation of this line is, so it's a vertical line, so we know it's going to be x equals, and it goes through negative 2, so it'll be x equals negative 2. All right, and that's a little intro to Locus theorem 3, equidistant from 2 points. Hope this video helps. Take care.